Okay, so now let's look at data. So now let's look at data transformation. So this topic is very, very important, and you'll be covering this in a lot of depth next year, because it is a very important technique when we're dealing with data. And most of the data in real life is actually transformed. It's not original. And the reason why we need to transform data is because sometimes the data might not be linear. So remember when we were looking at data analysis, we were looking at linear versus non-linear data. So linear was when it was a straight line, and non-linear when it was anything besides a straight line. So what is a straight line? In order to construct the line of best fit, it's very easy, It's very easy. You just pop the data in your calculator and it gives you a line that represents this. But what about if it's not a straight line? What if it's something like this? Now, if you do try to construct a straight line or do linear regression, you'll get something like this. But it does not represent this part of the data, or in fact, it does not even represent this part of the data accurately. So what we do is we do something called the data transformation. So if a data is non-linear, what we do is we convert it into linear data, and something that we can essentially graph or model. Now, there's multiple different transformations, and you'll be looking at even more next year. But for year 11 or unit 2, you need to know these basic ones. So we either have the log, the reciprocal, or the square transformation. And now the type of transformation that you will need to apply will be determined by the sort of graph that you have. So first step is always to sketch out a scatter plot of your data. And once you've got a scatter plot of your data, look at the data and determine the shape. So if my shape is sort of like this, then I need to apply one of these transformations. I'll show you guys how to apply these transformations, so don't worry about that. But just for now, try to appreciate the different transformations that are available and when we need to apply them. So these ones are only looking at transformations to the x variables. Now you will also be looking at transformations to the y variables, but we won't be covering that in today's lecture. Because that is more year 12 stuff. Okay, so depending on the shape of the graph, we select an appropriate transformation. So let's look at an example, okay? Because that's the best way to understand data transformations. So here we have our data, okay? They've given us a random set of data. What do we do? First step, always determine an appropriate transformation depending on the shape of the graph. So in order to determine the shape of the graph, we need to sketch it out. So here it is. So we've sketched this graph out on our calculator, and it looks something like this. Next step is use the circle of transformations, so what we saw in the previous slide, and determine the most appropriate transformation. So my graph is sort of like this, right? So therefore, it's this one over here. So therefore, the appropriate transformation is x squared. So then what we do is we transform our data. And the way that we do this is on our calculator. Again, we won't be going through the specifics of how to do it on our calculator. But if you want me to tell you, or you want some guidance, let me know in the chat. So all we do is we do x squared on our calculator, and as you can see, the x values have all been squared. So 2 becomes 4, 3 becomes 9, 4 should be 16. 5 becomes 25, and 6 becomes 36. So the x values have all been squared. Next step is, so the next step is, there we go. So the next step is actually plotting the data on our calculator, and all we need to do is, instead of using the x values, so remember when we were looking at data analysis, we worked out that linear regression line. So instead of using the x and the y values, we use the new x squared. So we use this list and this list to sketch our data or to model it. So that's the whole point of data transformation. It's to transform the data so that it will linearize. So now when you sketch this data, what it will do is it will sort of stretch the values out so they look linear. Okay? So that's what the x squared transformation does. Okay, so now let's look at modeling nonlinear data. So, we looked at linear data, and linear data can be modeled by a linear regression line.